All right, we're going to get started now. So the next session in the Spotlight track is BlackSky, Advancing the Geospatial Revolution with a Cloud-First Approach. And we're going to do a speech, and then when you do the Q&A, I'd ask if you could queue behind the microphones this time. It's just a little bit easier for us for logistics. Also, I'd like to remind everyone, do feedback in the app. So, my pleasure to introduce Robert Kahn, the Director of Software Engineering for Space Operations, and Scott Herman, the Vice President of BlackSky Product Development. Thank you both.
So good afternoon, everybody. Thanks for joining us. We're going to talk a little bit about BlackSky and SpaceFlight Industries, some of the projects that we're working on, and in particular, how we use Amazon Web Services as really the critical infrastructure that we build our mission requirements, our functional services, our customer-facing interfaces on top of. We'll talk a little bit about the type of missions that we're using Amazon for. We'll go into a little bit of the architecture, and then we'll do some Q&A at the end. Really, our premise at BlackSky is that the world is becoming increasingly instrumented. Sensor networks are proliferating, and they're proliferating not only in space, but in the air, on the ground, even on and under the sea. Even our cell phones are sensors. And so we look at the world from the perspective of global monitoring. How do we view the world in terms of emerging crises or threats to the supply chain of a commercial industry? Or what are our competitors doing? What are they up to? And how can I find out about that through the use of remote sensing and global monitoring type of products? The way we do that is through a collection of kind of 4 different systems or processes or functional areas. The first of those is what we call our global collection network. And this is really how do we tap in to the proliferating sensor networks that are rising around the world. Not only what's happening in terms of small sats, what's happening in terms of the rise of the drones, what's happening in industrial IoT, and again, even things like cell phones as sensors. How do we bring that in? When we bring all the data in, we're now trying to figure out what kind of global activity is happening and what kind of monitoring can we do to provide things like indications of warning, trending of commodities and supply chains. What does your extended partner look like? What kind of risks do you have in your operational business flow? Or obviously, from a national security perspective, what are potential bad actors doing and how do we kind of prepare for that? The third thing that we're doing is once we have all this data brought in, is we're running a set of analytics against it to provide what you might almost call hyper-local insight, very, very precise geoprecision of events that are occurring around the world, along with assessments of magnitudes and risk factors and scoring to help us figure out what do we need to bring to people's attention. There's a tidal wave of data out there. There's an even greater tidal wave coming as more and more sensor networks proliferate. How do we make sense of that? In addition to using lots of existing sensors and emerging sensors that are out there, the fourth component is we're actually building one of our own sensor networks, and that's what we call the BlackSky constellation. It's a constellation of satellites for remote sensing that will provide us premium fuel for our analytics engine that we can combine with many, many other sources of data. So that's kind of our premise. What this allows us to do is to give our customers what we consider global monitoring services. And that can be tasking and collection services, being able to tell satellites or being able to task or pulse sensor networks to get information back about particular issues, whether they be adversaries or competitors or even your own extended supply chain. We're doing global monitoring. What is happening in the world and what is emerging as potential threats to your country or to your business? How do we watch for those emerging threats? How do we do anticipatory or predictive analytics against that to kind of forecast what may be happening? And then how do we provide meaningful geospatial intelligence reporting against that can be used not only by sophisticated kind of national security, public sector community audiences, but laymen, construction foremen, a hedge fund analyst, a business operator who's trying to figure out how does my extended supply chain in Europe, how did the flooding impact the factories that I'm dependent upon? in terms of the constellation that we're building, in addition to using lots of the satellites and drones and industrial IoT sensors, asset tracking sensors, environmental sensors that are out there, we're building our own constellation. And the goal is to build up to 60 satellites, put them into a constellation that is really looking at the Earth with a revisit rate of up to 15 minutes, every 15 minutes over a particular area. So when we talk about intraday revisit, the goal is to be able to get that up into the anywhere from 12 to 24 times a day revisit over a fixed facility. We are not a mapping program. We're really not trying to develop base maps. We're not building mosaics. We are a point target collector that is specifically tuned toward facilities. So a typical use case for us with our customers is, I have 300 facilities in country X that I want to monitor, and I want to understand anytime there is significant change in those facilities, there may be an indicator of activity that I need to pay attention to. So a very different model from a traditional remote sensing or mapping type mission, where we're collecting 24/7, we're collecting daytime, nighttime, we're collecting across multiple phenomenologies, and we're really trying to zero in on a set of facilities, understand the pattern of life associated with those facilities, and give indications and warning based on that. So this is a picture of our very first satellite. This is back in 2016. We launched a Pathfinder satellite, a prototype satellite. Learn how to fly, test some of the flight components, make sure it's ready to go. This is sitting on the pad in southern India. This was launched with one of our partners, the Indian Space Agency, on what's called a PSLV, which is a polar orbiting launch vehicle. And up it goes. And you can see our mission patch down there in the corner. Basically, when we talk about Amazon Web Services, how does this mix of sensor networks and analytics and global monitoring kind of fit together? Well, we are all in on Amazon. Everything we do runs on Amazon. Everything we have is in a Amazon architecture. That includes our big data analytics, that includes our user interfaces, customer order fulfillment, satellite mission planning, constellation management, image processing of the data coming off of the satellites, both third-party satellites and our own satellites. It's all in. Our poor IT team has really one job, and that's to issue laptops and keep the mail server running. Everything else is in Amazon, and we'll talk about that in a little bit more detail in just a minute. The other thing that we do is we use a very wide range of Amazon services, not just the typical S3 and EC2, but literally we use more than 75 different Amazon services. If Amazon has offered a service that does what we need to do, we're going to jump on that and make that part of our core architecture. We have kind of a running joke. We send a team to reInvent every fall, and they come back and go, we got 10 more services we need to add to our architecture. So it kind of goes to the point that you don't want to reinvent the wheel. There's a lot of things that are constantly being developed as part of the Amazon services infrastructure that we can leverage. We are cloud first. We are cloud architected. We are not rehosted. We are not lift and shift. This is really about big data analytics designed to use the scalable, elastic infrastructure that we get by pretty much betting it all on Amazon as our core infrastructure provider. The other thing I would mention is that we use a combination of public Amazon Web Services, but we also run part of our architecture in GovCloud. And Robert's going to talk a little bit about the reasons we do that. And we also have a presence on C2S, if you know what that is. So what I'm going to do is I'm going to talk a little bit about kind of the customer-facing part of the BlackSky Global Monitoring offering. And then Robert's going to come up and talk a little bit about how we use Amazon in terms of our technical architecture for what's happening behind the scenes with our constellation. How do we run our space systems? How do we do our mission planning? How do we do our image processing? So basically, when we talk about BlackSky as a set of monitoring services, the conceptual architecture looks something like this. On the left-hand side, we're pulling in data from a wide range of sensor networks. This is high volume, high velocity, millions of hits per day data. This is a big data problem. This is a streaming data problem. This is a near real-time data problem. And it spans space and air and ground and water and cell phones and anything you can kind of put together. If we can find it as a data source, we're going to try to figure out how to bring it in and exploit that data to get a better understanding of the kind of things that are happening on the Earth that could impact your organizational entity. Along the bottom, one of the things that's really important for us is places, facilities. What are my 300 facilities worldwide, and how do I monitor what's going on, and what are the threats to my facilities? What are my competitors' facilities or my adversaries' facilities? What is my extended supply chain? Who am I dependent upon upstream and downstream in my business operations? And what's going on with them that I may want to have an understanding of? And then the output from all of this is a series of lightweight web interfaces, mobile interfaces, data streams, and APIs that can push this data into other systems. We do not want to be yet another stovepipe, certainly in a public sector agency. What we want to do is feed these high-value, refined events and alerts into the systems of record that you may already be dealing with. So the APIs and outbound data feeds and alerts are a very big part of what we're putting together. So here's an example. This is a screen that's basically showing a density of observation. That's the heat map. So millions of observations per day, and we're kind of showing where's the intensity of those observations. But the icons are the events that the system is scoring and thresholding, providing better precision and accuracy to, and saying, hey, analyst, hey, operator, hey, business leader, you need to pay attention to this. This is happening in the proximity of a place that you care about. So I'll give you a couple examples of that. We basically take the world's data and we try to sort and organize it in near real time into different thematic, what we call channels. So it's almost like you get the sports package, and inside of it you can watch football or hockey, right? So we kind of do the same thing. We say we have a whole collection of events related to crime or geopolitical conflict or environmental danger, humanitarian refugee, new construction, and particularly around industries like energy or oil and gas. Within those channel topics, you can select the programming that you care about. So maybe I care about geopolitical conflict as a channel, but what I want to focus on is the Turkish incursion into the Afrin area of Syria, and I can tune that dial down and have that as a very specific feed of information flowing to me across all of these different data sources. So as an example, this is one of our dashboards. It's almost a Netflix type thing where you can flow around it. You see these things streaming in. You can hover over them. It'll tell you kind of what's going on. You can see some of the things I've been interested in lately, the Qatar blockade, refugee issues in Myanmar, earthquake warnings coming from seismic networks. We had mentioned the incursion by Turkey into Syria, what's happening in terms of Iranian protest. These are all things that I as an end user can tune and share within my organization based on these higher level topics like crime, refugee, geopolitical conflict, and natural disaster. Here's an example where I've drilled into one of those. And again, all hosted in Amazon. I'll talk about the architecture behind this in just a minute. But you can see some of the scoring. What is our confidence around this particular event? What's the geolocational accuracy? What are the sources that we use? A particular event may have come from literally hundreds of sources across different phenomenology. It may be social media, it may be news, it may be satellite imagery, it may be industrial IoT data, it may be scientific instrumentation data. All those different things can feed into these common aggregated topics and channels. Here's an example where we're actually looking at industrial IoT data across an extended supply chain. And this is actually Mitsui, which is a Japanese heavy industry conglomerate, and their iron ore commodity supply chain, where it starts with the mines in Australia, Western Australia. We're tracking the heavy mover dump truck equipment. We're tracking it as it gets on the trains and is loaded onto these giant mile-long ore trains. We track every train as it's moving around. We track the ore as it flows into the ports in northern Australia. We track backups into the ports, congestion, what are the impacts to the ports from things like labor unrest or cyclones. That's been a big thing this year. And then we track the ships themselves across all of the different, company entities, and where are their destinations, where are they going, what's the tonnage, what's the throughput, and that gives us some really interesting things we can do around commodity trading. And the one chart that you see in the lower right, that is actually us showing a series of 2 to 3 week leading indicators, where by watching what was happening in the ports and in the mechanics of the supply chain, trucks, trains, mining equipment, we were able to get 2 to 3 week leading indicators against the coal and iron ore indices coming out of Australia. And if you're a hedge fund, that's really important. Anomalies make money. Predictions make money. And that's very much what we're focused on. Here's another example. We've been tracking some Chinese oil smuggling. This is in a oil transshipment port near Singapore. In this case, what we've done is we've said we want to go out and pulse the network of news and social media and figure out what are the investment issues and the ownership issues around this particular facility. So we've gone out and canvassed and brought this data back, put it through a pipeline of natural language processing. I'll go into that in just a little bit, all running on Amazon, of course, to give me some sense of what's happening around this area that might give me some clues as to what's going on. And then I'm going to switch gears completely. I'm going to say, well, I also want to understand imagery over this facility. So tell me all the imagery that's available recently for this area. And so you can see we're pulling back imagery from a wide variety of providers. Some of these providers may be people you already work with, as well as some you may not have heard of. And we're pulling back electro-optical imagery or SAR imagery or RF collection. There's a lot of different phenomenology we can bring to bear. But it almost becomes an Amazon.com-like e-commerce interface to be able to get at geospatial data over facilities that you care about. Here's another example. This is Africa. This is every image collected in the last 12 months that has 20% or better cloud cover from a quality perspective. And then each color that you're seeing there for each of the polygons on the map represents a different satellite system that's providing the imagery in that area. So for example, the light blue kind of aqua color is Airbus Pleiades. You can see there's some dense concentrations over the Middle East and over the former French colonies of Western Africa. No surprise there. So let me talk about Amazon Web Services in particular. Now this is a dense chart and I'm not going to go into every little block, but there's several key takeaways I want you to get from this chart. Number one is every component that you see is running in Amazon Web Services. We run a microservices architecture. We use immutable containers, Docker containers, to do provisioning. We do continuous integration, continuous deployment across this collection of servers. It's all auto-scaled so that as we get demand from inbound data or we get demand from users on the demand side, everything can scale up and down. Our Pilot Light mode, Pilot Light is the smallest configuration, is about 70 servers running continuously, processing all these millions of observations that come in, organizing them into these event streams, and then pushing out the alerts and notifications across a variety of interfaces. Scaling up, they can literally scale up to thousands of nodes as we burst against different types of data. So this is really the epitome of elastic computing in terms of auto-scale. Because of that, that means we have to spend a lot of time thinking about cost. And that means things like reserve instances versus spot instances in the auction. And how do we architect our microservices so that each one is immutable and discrete and serves a particular function, but we're not wasting efficiency by having a whole bunch of services that are sitting idle most of the time, chewing up compute cost. So if that's something you're interested in, I can do hours on that topic alone, but it's very much a factor for us in thinking about how do you run a complex, big data, high-performance compute architecture within Amazon where you don't have an unlimited budget. This is a cost of goods sold for the revenue that we generate with our customers. So cost is a big factor. Let me talk a little bit about some of the things on the chart real quick. One of the big takeaways is that we're pulling in all of this data across all these different phenomenologies. Different data requires different processing requirements. There's not a one-size-fits-all. It's not throw it into S3 or throw it into Elastic and run queries against it. What we're trying to do in most cases is we're trying to extract entities or determine features or establish correlation and fusion across these different data sources. So the first one you'll see on there is what we call our narrative pipeline. Narrative means text processing. So that's industry publications, it's social media, it's hyperlocal news. We bring in over 40 to 50,000 different hyperlocal news services across dozens and dozens of languages. This is a natural language processing, NLP, pipeline. And it's primarily based on Lambda and Kinesis, running a lot of our algorithms around doing NLP, entity extraction, geoprecision, and accuracy. So that's one type of technology stack within the platform. Another one I want to point out is the tracker pipeline. This is for tracking movers. These are things like, where are all the cell phones at? Where are all the ships at? Where are all the airplanes at? Where's the mining equipment? How long does it take to get from point A to point B? When is there ingress or egress from a particular area of interest, a particular boundary condition? What's the magnitude of tracks within a particular area, like a port? What's the linger or loiter time, the hang time of things that are moving in and out of a particular facility? That's all mapped into our tracker pipeline. That's running on Amazon using technologies like Spark and Parquet. And again, I can talk to you offline if you want to learn more about that. The final one I wanted to touch base on is the way we do some of our image processing. And what we're doing for image processing is we are doing pattern recognition through machine learning and computer vision. And we're doing this not only for satellite imagery, we're also doing this for the photos that can be harvested from places like news and social media. So find me every image, every iPhone image that has a crowd in it, or a fire in it, or a flag in it, or one of our favorites is find me camouflage, right? Any social media image that has camouflage in it might be interesting. It could be a fashion statement, could be something a little more interesting, and we'll find out. One of the interesting anecdotes I'll talk about before I turn over to Robert in this pattern recognition image processing chain where we're doing entity extraction, feature extraction, and pattern recognition. And by the way, that's a TensorFlow based architecture that we've made some heavy refinements to. We were looking for tanks in Eastern Europe and trying to do very, very broad surveys, not only from overhead imagery, but from social media and news media around when did tanks show up. Well, like in the United States, every small town has a statue of like a Confederate soldier or a Union soldier. In Eastern Europe, every small town has a T-34 tank from World War II on a pedestal. And every one of those shows up as a legitimate hit on armor in our pattern recognition. So we had to tune and figure out how do we more precisely exclude certain types as well as not, losing legitimate pictures of armor within those images. So that's an example of the kind of work that's happening in that pipeline. Across all those pipelines, we generate a set of events. Those events are categorized, fused across phenomenology, and then if they meet certain alert conditions, they're thrown out to operators, analysts, users to say, hey, you need to pay attention to this. So that's kind of the idea that's going on here. Again, all based on a fairly large menagerie of not only Amazon-based services, but some of the new cutting-edge technologies that are being used for things like big data processing, natural language processing, image processing, et cetera. So with that, I'm going to turn it over to Robert, who's going to talk a little bit about how we use Amazon Web Services in the back office, right? And our back office isn't just finance and accounting, it's running a satellite network and dealing with the ground control. Robert?
Hi there. So again, my name is Robert Kahn. I am Director of Software Engineering for Space Operations at SpaceFlight Industries, of which BlackSky is a part. That means I am responsible for the software that runs on the satellite itself, doing things like command and sequencing, radio communications, and also attitude determination and control so we can actually point at a particular target. I'm also responsible for software that runs in the ground stations themselves. Ground stations have amazing number of components in them, and we have to do things like set up the radios, sequence and control antennas so that they point at the satellite while it goes by, and then when everything's done, where we've pulled everything down for the satellite, relay it all the way back to Amazon, where we control the system and make decisions on what to do next. And one interesting thing about that is that as a US company, controlling a satellite network requires that you issue commands from a location on the US soil, and Amazon GovCloud really helps us out in that case. So what you see here is a picture of what our constellation will look like. On the left, you see the orbits that would be going around the Earth. Some of them are in sun-synchronous orbit, and some of them are in inclined orbit so that they go over populated areas more. And then again, on the right there is the first two satellites that we launched called the Pathfinder series. We launched them in 2016. That mission is now over, and I'm completely focused on our next generation satellite. Here's a picture that was taken by the Pathfinder satellite of North Korea on an airport that was just built. All the pictures that we took of that never showed an airplane on the runways itself. but it gives you an example of what we were able to do just with the Pathfinder satellite, which was, again, just experimental. So now I'm going to talk a little bit about how the concept of operations in our ground stations. So this one is kind of a bit of eye candy here, but if you look in the lower right, you can see a customer is making a decision to order something. So it's tasked through Scott's platform. And then we have to send that to our centralized system where it will say which satellites are available, and then something we call Mission Planner will determine which satellites will take pictures and when. And then we have to send them out to the ground stations where the instructions will be uploaded to the satellite. Satellite will collect the picture, and then it will download it at the next available ground station where we have chosen which picture will be downloaded first so that it can be delivered to the customer that has the most need the fastest. Once it gets back down to the ground, then we send it through an image processing pipeline to generate the nice picture. We run it through some quality checks. If we don't like the quality check, we'll retask it and take the picture again. If we do like it, then we give it off to Scott's system, and he takes it from there. So what this shows is an example of two of our ground stations. In the upper left there is our ground station in Fairbanks. That's a 7-meter X-band dish and S-band dish that we use to do high-speed communications with the satellite. And then one in the lower right is our one in Invercargill, New Zealand. You can notice that we have one very far north, one very far south, and some of them in the middle are ideal for what I call those inclined orbits, but when you're doing sun-synchronous orbit, the farther north you are, the farther south you are is best. So now what this shows is, there's a lot of detail on this slide, so I'll try to go through this. This is the satellite operations architecture, and on the very top there is the platform operations and business systems that Scott has. And then we get down to the next layer where my work starts, and that's the ground and control software as well as imaging operations. So again, in ground and control software, when we get orders in from the platform saying take pictures here or there, then we give it to the mission management system. It makes a decision what to do and sends it off, but it also then relays everything to the ground station where the radio chain will then upload it to the system. And then we will exchange information with a satellite, bringing down a bunch of telemetry, and then we will send that telemetry back to our system to say, is the satellite running correctly? Were all the pictures taken? Did everything work right? And go from there. When you look at the ground station hardware kind of in the middle left in the green there, that shows that we do UHF communications, X and S-band communications for high-speed communication, and then there's a server on there that orchestrates everything together. So there's, like I said, many moving parts in a ground station, and our software controls all of that. And then on the space side, you can see in the blue is attitude determination and control, command and data handling, which I called command and sequencing. We also do telemetry and monitoring, so if something goes wrong with the satellite, it will put itself into a safe state and relay that information to us. And then we have what's called the electrical power system. And one of the things you have to do when you develop satellite software is you have to control every single aspect of what it does. And so we have to turn everything off. When we're getting ready to do radio communications, we have to turn on the radios. When we're getting ready to take a picture, we have to turn on our Palos interface card, turn on the camera, point everything at the ground, and start taking pictures. And then when you look at the one that's in purple, that's kind of more of the hardware aspect of it, and there's, again, almost as many parts in the satellite as there are in the ground station, and the flight software controls all of that. So, but you guys are here to hear about AWS, not the insides of my satellite, and so our BlackSky satellite system was designed for AWS from the beginning. We do all of our space operations on AWS, and we use AWS for multiple environments, which I'll go into some more detail. And then one thing that's been really helpful for end-to-end development is using AWS for satellite and ground station simulations. We also do automated provisioning of our environments. We use VPC networks to connect all of our ground stations back to our central services. And then we love to use hosted services such as Elasticsearch or RDS for databases, or SQS for sending messages from one system to another saying, hey, pictures arrived, start processing them. And then I'll talk a little bit about consequences of designing for AWS, because it's in the satellite business, it's not consequence free, and a little bit about our future goals. So our system was designed from scratch for AWS. We designed the system for lights out operation. We have a room that we call the Mission Operations Center, and when we were doing early, what they call launch and early operations of the satellite, a whole bunch of people climb into that room. We do a whole bunch of stuff. It's very small, it gets hot, don't like spending time in there, so we want it to be all lights out. We also designed with security in mind, so we do not use fortress security. There's many different ways that you would have to penetrate our system to be able to get to control of a satellite, which probably would mean breaking into GovCloud, which I think is a pretty tough thing. All of our systems run Python on Linux in Docker containers distributed on managed EC2 instances, and I'll talk a little bit about that. But a really important thing for satellite operations is that GovCloud provides ITAR and EAR compliance. As I said, when you command a satellite, whether it's in our Mission Operations Center or automated systems running in GovCloud, they must be located on US soil, and GovCloud gives us all of that. We have a direct connect from our Mission Operations Center to the GovCloud, which allows us to securely command satellite operations. But the thing that I would like the best, because I'm a software engineer and I like to build things, is that we used physical and mock satellites and ground stations to test the system from the very beginning, and also develop the flight software. And the nice thing about that is that when we had problems with, say, with encryption between the satellite and the ground, we were able to resolve it end to end without having to say, oh, we got into space and we can't talk to our satellite because the key isn't working, which would be absolutely devastating. So I'll give you some examples of the things that we do on AWS. We do mission planning, so we are building a multi-satellite system. We decide which satellite is going to take which picture by looking at the entire system holistically. We have people who are experts in, what's the right word, for determining where the satellite's going to be, all of the things related to that, and then those are aerospace engineers, and they've developed a mission planning system which then tells constellation management, this is what I want to do. Constellation management will then tell the ground stations, hey, here's the new instructions for satellite X, upload that, download these pictures, relay them back in this order so that they can be processed. We have something called a mission script builder, which will take the commands that were generated by mission planning and constellation management, securely encrypt them and send them out to the ground station, because you cannot make decisions on which command to generate at the ground because it's likely that the ground is not located in the US, and so we have to send that all encrypted so that nobody can break into it and figure out what's going on. We have something called the satellite model, which keeps track of all the satellites. We have a tasking interface, which Scott Systems will use to say, hey, take a picture of this. And then we also have something called an ephemera service, will tell you where the satellites are right now and in the future, so that when Scott's customers are saying, hey, I want to take a picture, that system can say, hey, this is your next opportunity to take it is in 4 hours, when the satellite will go over your target. And then we also have something that's related to that is the image feasibility service. And then we do all telemetry and monitoring on the ground. So every time we connect to a satellite, we get a stream of historical and real-time telemetry, and we make instance decisions on what to do with that. All the stuff that's on the right there is very specific and very esoteric to space operations. So if you have questions about that, you can ask me after the presentation. Again, this is my favorite slide because I like building satellites, I like operating them, but building them is the best. And if we look at the bottom slide there, what you see on the left is what how the satellite is emulated on an Amazon EC2 instance. And then we have an emulated ground system right next to it, and in the very back is the constellation management, which is running in the cloud. The nice thing about all of this is that we are able to define new environments on demand. So an example of that would be our development environment. This is when we test, the developers are working on it. There's no physical hardware involved. Everything's purely virtual. And then we say, okay, now we have a staging system that looks just like production, but we want to test our updates there. But we have another environment called ops test, because I don't actually get to run the satellites as much as I would like to. That's for aerospace engineers, and they need an environment to be able to test the interface for operating the satellite. And so they can have their own, we can have dev, we can have stage and production all at the same time. But spaceflight doesn't just do satellites, we also do launch services. That can be as simple as A meet B, A has a rocket, B has a satellite, they go off and solve those problems. But it can be something as complex as what we'll do later this year, which is to have SpaceX launch our own Falcon 9, which will have almost 100 satellites in it, including some of our own. And when we do that, we have to suddenly roll out special environments. We don't know they're coming, we just get launch services says, hey, we need this now, and we're able to spin that up really quickly. Now I want to move on to AWS for ground and for satellite and ground station simulation. So we designed the system to run all of the satellites right from the very beginning. And because we can emulate satellites, we just spun up, hey, we need 60 satellites to try this out. But that requires the use of certain emulation environments because satellites are notorious for being very old hardware. They're like your Mac from 20 years ago. And so they use power PCs, so we have to run that emulation software, but it just runs on a regular AWS Linux instance running x64. This allows us to test our system at scale, so all the planning, all the constellation management's tested at scale. And the nice thing about it is I can arbitrarily combine real hardware and fake emulated hardware at the same time. So if I want to hook this system up to a real satellite in one of our test facilities, I can do that. If I want to use real ground station equipment, I can do that. And all the time controlled by either our production systems or dev and stage systems for controlling it all. Again, now getting into some more of the esoteric things. So some of the things that we do to be able to manage all of these environments is that we use tools for automated provisioning. What they do is they provision all the EC2 instances, all the S3 storage, all the connectivity, everything, including secrets management, cluster management, and providing DNS and configuration management to the ground system. So the ground systems need to know what to talk to back in GovCloud because they're relaying information back, and all these automated processes take care of that for us. I'll have some feedback on that when I get to our future goals. One thing that's really good is that we use transit VPC networks. This is a relatively new feature from Amazon. As soon as we knew it was available, we jumped on it right away because what this allows us to do is define software firewalls between all the systems and very easily configure them at a very fine level to connect various things. So I can say one part of a ground station can connect to GovCloud, but it can't connect to anything else like our corporate systems. And then we do use a number of hosted services. RDS provides database services. Elasticsearch is a system that takes all of our telemetry, all of the syslogs that come down from the satellites and from all of our ground stations, all go into Elasticsearch, and then we can then query that as a way to generate alerts and notifications to the operators. And then a very simple thing is just the SQS, which allows us to send a message. So say when the satellite has just finished downloading all of the images and is about to relay them to the cloud, then we can send a message through this queuing service, and it just is delivered, and the cloud will start acting on it. Again, the nice things about these is we don't have to do anything with them. They're just there. We just provision them and say go. One thing, all of our telemetry goes into Elasticsearch, and it's very nice that the government allows us to do that outside GovCloud so that it can be visible to everybody that's interested inside our company. Someday Elasticsearch will be available inside GovCloud, and that will be a good thing as well. So there are some consequences for designing from AWS, and it is really apparent to when you work with hardware versus working with pure software like Scott gets to do. We have physical ground stations. We have to put a satellite, take it out to a launch facility, test it to make sure it's working correctly there, and that means you have to hook up something to it that's just like the ground station. These are all physical boxes. There's no internet connection when you're standing on top of a rocket hooking your satellite on, and so we have to roll out stuff that's compatible both on the launch pad as well as in the cloud. This allows us to develop for one platform instead of two, but it limits some of the services that we're able to use. Now, fortunately, there's some emulation technology like Minio, which provides S3 services to us. That mitigates it somewhat, but we are very limited in what we can use for satellite development and operations. We've also experienced problems with bandwidth and latency issues between GovCloud and our corporate assets. This can be kind of frustrating because Amazon often fails to provide meaningful information during these outages. There's nothing more frustrating when we say, all of our systems are down, nothing's working, and you're showing a green indicator there, and so that can be a little frustrating. It's getting better. Sometimes though, when Amazon is trying to make these things work, they will send very cryptic messages, and you have to have experience to understand whether something is serious or not. And then the other thing is that Amazon gates features that go into GovCloud. You can only do so many things because they're wanting to ensure ITAR compliance, and that usually means that GovCloud is technologically behind the other availability zones. Too long didn't read. GovCloud is not the same thing as fully featured AWS. So now getting to some of our future goals. One thing that we want to do is stop using any third-party tools that we can and be 100% compliant and use all the technology that's available in Amazon. So one of the things we'll move to is their support for Docker containers. Right now we have some very specific requirements that are not met. As soon as they are, we'll switch over. All of our systems are extremely distributed. There's a lot of instances running, and so we are using a different technology for cluster management so that our systems redeploy right when there's failures, but we really want to use Amazon's container management in the future. And anything that they come up to replace any third-party tool, we want to do that. And then sometimes things happen that are not super urgent or they don't require a lot of processing power to be available 24/7, and so we want to use Lambda systems for that so that we can just have it react to an event and do the work that we want. So, Scott, I think you can go ahead and take this one.
Yeah, so we're almost done, and then we'll do some Q&A. One of the things we wanted to talk about a little bit is about what are we doing to process the imagery that's coming off of the satellite, and what are the steps there? Well, one thing you have to do is get it from the ground communications network back home. Where is its permanent archive? Where is its permanent storage going to be? We actually use Amazon as a backhaul mechanism from ground systems around the world. That's a very powerful technique. It's a best practice that you should think about if you've got distributed ground systems and you're trying to think about how do I buy lease lines and fiber optic and everything else. But if you've got an Amazon node nearby, you can actually use S3 as a backhaul mechanism. So really interesting idea that we've been very happy with. When we bring the imagery back, unlike a lot of the kind of big Battlestar Galacticas that are flying around right now that require some fairly complex assembly of the images coming back, we're almost a giant webcam in space. It's a single frame CCD, so what's actually downloaded from the satellite itself is a complete image that's ready for dissemination to customers. That also gives us future capability around direct downlink, so a little note for some people in the crowd that may be interested in that. So there's not a lot we have to do. There's things around georectification, there's things around orthorectification. We've had to put a lot of thought into how do we affordably do that. One of the big value propositions of what we're trying to do with BlackSky Global Monitoring and the BlackSky constellation that's feeding that global monitoring service is to make it much more affordable than traditional satellite imagery or imagery-derived analytics have been in the past. Rather than multiple dollars per square kilometer, can we get that down to a transaction that almost starts feeling like a consumer-grade, run-your-credit card type experience? To do that, that means things like our image processing chain, our archive cost, our processing cost are all things that we have to manage very carefully. And we have to think about what services we use to do the refinement of the images. So even things like what kind of topo, what kind of elevation data do we use in order to do our orthorectification, that, because all of our other costs are so low, that actually can spike and become one of the larger costs in the processing chain. So that's some of the things that we have to watch out for. So in terms of conclusions, we'll do some questions here in just a minute. But the big takeaways is that we hope we've proven that you can actually build the entire stack to support satellite remote sensing within the Amazon cloud environment. Not only the customer-facing applications or the big data analytics, geospatial analytics applications, but even things like mission control and constellation management and ordering and fulfillment and image processing can all be done in the Amazon cloud, and that drives a lot of cost efficiencies for us. It drives a lot of agile velocity for us. And more, as more services, both Amazon services and third-party services mature, it becomes a Lego block exercise rather than multiple years of development of unique capabilities. So I hope that's something you take out of this. So with that, I guess we have a couple minutes for questions.
3 minutes. Maybe we take 1 or 2 questions. Yeah, please walk over. We've got 2 microphones in the aisle.
Good evening and thanks. Just quick question on your emulation scenarios. Were you able to dig into services like the FPGA services on Amazon for part of your simulation, or how did you actually pull in some of those spacecraft simulation aspects?
So that's a good question. So when we do spacecraft simulation, some things are not easy to emulate, and you mentioned FPGA services. Now that'll be a technology I'd like to look at, but only about half of the spacecraft is controlled by what would be considered traditional software. A lot of it is controlled by FPGA systems. So we have developers that are focused on just HDL. When you're going to say, I want to move an image from the camera frame grabber into the NAND flash that's storing it, that's much easier to do with FPGA than we can with software. And that's how it's implemented on the spacecraft, but we just have to kind of emulate that in a very kind of crude way, but that is embedded into our software because the software that runs in the simulation environment is exactly the same software that's running on the satellite itself.
I have a question about geo events that you mentioned in the beginning. So when you generate an event when an asset leaves certain region or so are you using any third-party solutions for that, or did you build it yourself?
So in general, what we do, and this is true across the entire architecture, we, as much as possible, take advantage of things that are happening in the open source community. Are there algorithms coming out of academia or other parts of the open source community that we can take advantage of? But a lot of it is our own intellectual property to determine exactly what we're doing. We do have third-party partners, mostly around how do we get content to feed into the engine. We do have some technologies that we use internally, but in general, a lot of the stuff we're doing, because we are building it cloud native, is really take advantage of high-performance computing capability that's out there, but then tune, polish it, really put our own IP against it, because that's where the value is in those algorithms. Okay.
All right, let's thank Robert and Scott for a great
Thanks.
I do want to say one more thing. So one of the things that's great about being in the space business as a software engineer is you can do it. If you want to be in space and you're a software engineer, there are tremendous opportunities. And one of the things that will get you is a mission patch, just like that one that's on there. And that is really cool, let me tell you.
10-minute break, so we're going to be starting back up at 3:55, and the next is NGA, how public sector data is fueling innovation. Please remember to fill in your feedback in the session app.